Morning, good morning, good morning.
Good morning.
Morning.
Well, you guys are all the smart ones that you figured out what time class actually started because it's Friday.
Yeah, thank you. I was sitting there for 20 minutes waiting.
Well, you did the right thing. You sent a chat. And, I did post it on the start page that today was Friday.
I got a sloth.
Come on. Caden, what are you wearing?
A blanket. It's a sloth blanket.
Sloth.
It makes you
Yes.
look like a little bit more like an old man.
I'm just in my pajamas.
Do you know, it'd be nice if it was just us today.
It could be because
Yeah,
I guarantee you there's a bunch of people that didn't pay any attention, and they're saying, why isn't any of my teachers teaching right now? And then they're going to try to go to second period, and it's not going to be on the right time, and they're going to be very confused. And then halfway.
When is second period?
Well, no, technically this is still first period, but they'll figure it out halfway through the day.
We don't have a lunch. Our second period is lunch, and we don't have a lunch Zoom today.
Ah.
Oh, why not?
We have a test.
Well, I know first period has a Latin because I just got a notification that it was starting. All right, we're going to get going here. Get out your homework. Homework, yeah.
So you're saying I can't continue to be a handyman and try and break stuff?
No.
Remember how Ace always says, will I get in trouble for something I didn't do?
Yeah.
No? Okay, I didn't do my homework.
All right, here we go. I will call out the answers. 1 through 22 all. 1 through 22 all. Number 1 is 5. Number 2 is 3. Number 3 is 20. Number 4 is 6. Number 5 is 28. Number 6 is 36. Number 7 is 49. Number 8, big number, 162. Number 9, another big number, 242. Number 10 is 30. Number 11 is 70. Number 12 is 18. Number 13 is 4/7. Number 14 is 3/5. Number 15 is 4/7. Number 16 is 2/3. Number 17 is 2/5. Number 18 is 3/4. Number 19 is 9. Number 20 is 4. Number 21 is 8. And number 22 is 32. Any questions on that? Okay. Moving on today. So this is the second part. This is just a bit too much to do all in one day, which is why I broke it up into 2 days. So here is your homework. Remember, this is also posted on the assignment. So if you don't want to copy it down, you don't have to because it will show up on the assignment. All right, here we go. Continuation of equivalent fractions. Just to remind you of what we did before, last class we started off by showing you that some fractions represent exactly the same thing. So here's 4 different fractions that represent the middle between the numbers 0 and 1, 1/2, 2/4, 3/6, 4/8. Therefore, all of those fractions represent exactly the same value. Therefore, we call them equivalent fractions, even though visually and numerically they don't have the same numbers. But quantitatively, in other words, number-wise, they do represent the same value. All right, so equivalent fractions, you copied this definition down yesterday. These are just different, by different, they mean different numbers. Different fractions that represent the same value. So all of those fractions, these ones right here, all represent the same value, which is 1/2. All right, we made equivalent fractions last night for homework. Remember, what allows us to do this is the fact that all we're really doing is multiplying a fraction times 1. And recall that the property of 1, multiplication property of 1, is that when you multiply anything by 1, nothing happens, nothing changes. Okay, but instead of multiplying by 1, we're going to write 1 in a different form. 2 divided by 2 is actually the number 1, so we're really multiplying that bottom fraction there, 3/5, by 1, except it's in the form of 2 over 2. So you multiply the numerators with the numerators, denominators with denominators, you get 6/10, and 3/5 is literally the same fraction as 6/10. They're just in a different form, but they are equivalent fractions. All right. When they ask you to make an equivalent fraction, literally you just pick any whole number except for 0 or 1. Remember, 1 doesn't change anything. 0 would turn it into 0. But you choose any whole number larger than 1 and multiply the numerator and the denominator by that number, and you make it equivalent fractions. All right. You can also do the same thing with division, right? Any number divided by 1 is itself, so nothing changes. The only difference is instead of dividing by the form 1, we're going to write 1 in a different form. For instance, 4 over 4. Remember, 4 divided by 4 is still 1, so all I'm doing is dividing this fraction by 1. The difference is when you divide 12 by 4 and 20 by 4, you don't get 12/20ths, you get 3/5. So it turns out that 12/20ths and 3/5 are equivalent fractions. It's the same fraction, just in different form. The last thing we did yesterday is we reduced the fraction. Now, reducing the fraction is also called putting a fraction in lowest terms. Those are terms where the two numbers, the numerator and the denominator, are relatively prime to each other. So 3 and 4, the only common factor they have is the number 1. Remember, we define relatively prime as when the only common factor is 1. That doesn't mean that both 3 and 4 are prime. It means the combination of both of them and their common factors is only 1, so that's why we call them relatively prime. So when you put fractions in lowest terms, the two numbers will be relatively prime to each other. How do you know when they're not relatively prime? The one in red there. Well, when there is a number larger than 1 that goes into both the numerator and the denominator, in this case 2. So 4/10 could be reduced. Therefore, the process of reducing the fraction is what this is about. So 4/10 is not in lowest terms. We would actually have to reduce that fraction. How is that done? Well, it's done by division. We're going to divide 12 over 18 by its greatest common factor. So remember, to find the greatest common factor, this is what you kind of do in your head. You think of the two numbers, 12 and 18. You think of all the factors of 12, 1 and 12, 2 and 6, 3 and 4. You think of all the factors of 18, 1 and 18, 2 and 9, 3 and 6, and you find what's common in both lists. The largest, the greatest common factor in both lists is 6. So the GCF of 12 and 18 is 6. That's a lot of work just to find out what you're going to divide the numerator and the denominator by. We're going to divide the numerator and the denominator by 6. And we get, let's see, 12 divided by 6 is 2. 18 divided by 6 is 3. We get 2/3. That's method 1. It's called reducing by the greatest common factor. It is guaranteed to do the entire process in one step. Sometimes, however, you won't realize or won't be able to figure out the greatest common factor, especially when the numbers are very large. You are allowed to do this in an iterative process. In other words, multiple steps. Maybe you can't figure out that 6 goes into both, but you can figure out, hey, they're both even, so we could divide them by 2. So if we divide them by 2, 12 divided by 2 is 6, 18 divided by 2 is 9. We get to 6/9, and we still need to ask ourselves, are these relatively prime, or is it fully reduced? In this case, no, we can still divide by 3, and we get to our initial answer, the answer we got previously, which was 2/3. And I do want to point out 2 times 3 is 6. If we had divided by 6 from the start, the greatest common factor, we would have been done in one step. There's nothing wrong with doing it in multiple steps. I will say that technique number 2, you do a bunch of divisions, so the chance of making a mistake does increase. But most people would say this is the easiest one to remember. Coming up with the greatest common factor, especially when the numbers are very large, is a challenging thing to do. All right, so that's what we did yesterday. So new idea, here we go, new stuff for today. Today we will be making common denominators. And for those of you that know why we will be doing this, we must do this in order to add fractions or subtract fractions. All right, making common denominators. Most of you have had this class before, so I will be brief. Write this definition down, common denominators. This is when two or more fractions, tonight they will eventually ask you, I think, 3. When two or more fractions have the same denominator. Okay, that's pretty clear. That means you have 2 or more fractions, and they must have the same denominator. Check it out. I got a denominator of 4 on the one on the right, and I got a denominator of 4 on the one on the left. Okay, so those are 2 fractions that have common denominators. I'll pause now, let you catch up. Actually, it was just so I could take a drink. Okay. Okay, so what would be an example of non-common denominators? That would be when the 2 fractions do not have the same denominator. For instance, in red here, this denominator is 4, this denominator is 5, not common denominators. All right, visually, this is what it would look like. Imagine you had 2 pizzas. One is cut up into 6 slices, and one is cut up into 8 slices. Notice the slices of pizza are different. So if you wanted to give someone an equal slice, right, I would much rather have a slice from the slice of 6 than the one from 8 because it's larger. So it would be really hard to, I don't know, wrap your head around area and size and who's getting more, who's getting less if you're trying to combine these, because they would be different sizes. Also, this is the reason why we want to add things and subtract things. We need our slices to be the same size so that we can make some sense of the idea of adding and subtracting. We actually don't do adding, subtracting, multiplying, dividing until next chapter. This entire chapter is just on the basic concepts of fractions. All right, so if you tried to add 1/6 and 1/8, that would be kind of weird. You know, I'm not even sure what the answer would be visually. But if the slices were the same size, the denominator is the same size, then it would make sense, right? All right, so that's why we make common denominators. Like I said, hold off on your enthusiasm until next chapter when we actually do add, subtract, multiply, and divide. Yes, that was sarcasm. Okay, so our goal today is to make common denominators. So we're going to make common, that's it for today, make common denominators. The skill that we're going to use from last chapter is the least common multiple. Chapter 5, we did GCF, right? That's how you reduce fractions. Now LCM, that's how we make common denominators. Recall, this is going to be how it works. 2 fractions that do not have common denominators. Check it out, 4 and 5, not common denominators. We want to make common denominators. All right, how do you make common denominators? You look at just the denominators. I'm going to ignore the numerators for a second. So I'm just looking at the denominators, and I think about what is the LCM? What is the LCM of 4 and 5? So let's see, the LCM of 4 and 5. We'll see, can we remember how we do LCM? If you've forgotten how to do LCM, this is how it's done. We think of the 2 numbers and we think of not their factors, but their multiples. In other words, count by 4. 4, 8, 12, 16, 20. We write down 4 or 5 of these answers, and then we repeat that process for the other number. While we're doing that, we're thinking of this list, 8, 12, 16, 20. When we come to a match, that's the least common multiple. So 5, 10, 15, 20. Oh, check it out, 20's match. So the LCM of 4 and 5 is 20. That's going to be our common denominator. Okay, so the last step, yeah, it's a multiple step process. Once we find the common denominator, 20, is to make equivalent fractions of both fractions. So lots of scratch work for this homework. So we take the first fraction, 3/4. We want to make the denominator now not 4, but into a 20. This looks exactly like last night's homework. Hey, that's why we did it last night. So let's see, to go from 4 to 20, that would be, what do you think, Gavin? Multiply, divide?
5. Multiply.
Top and bottom by 5. So we multiply top and bottom by 5. This time, we are going to say the entire fraction. So let's see, 3 times 5 is 15. So 15 over 20, that would be the case. We're not done yet because there were 2 fractions, so we got to do it to the second fraction. Once again, we decided the common denominator was 20. The same process. What do you think? What times 5 is 20?
4.
Thank you. Therefore, the fraction 1 times 4 is 4, so 4 over 20. Now, we have common denominators. We would be allowed to add or subtract those numbers. Okay? That's what we're doing today. So that is a lot of work. I'll go back to it. We filled up the entire slide there. So this is one of the reasons why people, I would say that fractions is not their favorite thing, because fractions require lots of work. All right, one more time. 1/3 and 4/5. Let's see. So we're just looking at the denominators, 3 and 5. We're trying to find the common denominators. So let's see, 3 and 5, 3 and 5, 3, 6, 9, 12, 15. Some people do it that way. They count up with the lower one, or whichever one that they have the least knowledge of that's multiples. Like I know the multiples of 5 very well. So I would count up by 3 until I got to a multiple of 5. And that'll work as well too. So for most of us, we'd probably stop at 15. If you didn't realize that, then you would count by 5s, 5, 10, 15. Oh, look, matches. Okay. So the LCM is 15. In other words, the common denominator is 15. Now we make equivalent fractions. And you need to do this scratch work. Try not to do the whole thing in your head. So we write the first fraction. We want to turn the denominator into 15. Well, let's see. What times 3 is 15? Somebody?
5.
Thank you. Therefore, the fraction 1 times 5 is 5. We get 5 15s. First one's done. The second one, we need to turn it into a 15. What times 5 is 15?
3.
So top and bottom by 3, so we get 12 15s. Questions? All right. Let's do one. Write these two down. Beat me to the answer. For those of you that already know what you're doing. All right, we got 2/3 and 1/2. Let's see. We need to look at just the, we're not looking at the numerators yet. 3 and 2. I need the LCM of 3 and 2. 2, 4, 6, 8. Okay, for those of you that can do this in your head, as you count, you're thinking about 3 multiples as well too. So as soon as you get to a multiple of 3, 06, then you're done. Okay. So the common denominator is 6. Now to make equivalent fractions, we take the first fraction, 2/3. We want to turn into something over 6. What times 3 is 6? Somebody help me. What times 3 is 6?
2.
Top and bottom by 2, therefore the fraction is 4/6. Thank you. All right, second fraction. Now remember, we got to do it to both fractions. We're turning to something over 6. What times 2 is 6?
3.
Top and bottom times 3. We get 3 6, and we're done. 4 6 3 6. Anybody struggling with this? Nobody? Excellent. Excellent. Okay. Let's do a more challenging one. They get more challenging because the common denominator becomes more challenging. All right, 6 and 8, 6 and 8, 6 and 8. Let's see, I'm going to count by 6, 6, 12, 18, 24, 30. I'm going to count by 8 because I don't recognize the common denominator yet. 8, 16, 24. Okay. So for those of you that can do this in your head, great. All right. But others of you will need to write these down. All right. So the common denominator is 24. 24. So I write the first fraction, 1/6 is equal to something over 24. What times 6 is 24? Somebody?
4.
Thank you. Therefore, we get 4 24s. Now notice that my numerator here was 1. It's not 4 because I'm multiplying by 4. It's 4 because 4 times 1 is 4. Second one. What times 8 is 24?
3.
And 3 times 3 is 9, so we get 9 24s. We good on this?
Yes.
All right. Anyone need a more challenging one? Or you kind of go, oh, this is kind of more challenging. 9 and 12. Ew. All right,
No.
9 and 12. Anybody common denominator before we even start?
72.
72 would be a common denominator, but it's not going to be the least common multiple. Anybody?
Yes.
4.
Let me think about it.
4, my bad.
I had 72. 72 is a good answer. It's just
36.
36.
Right. So it is worth your time to do this process of trying to find the least common multiple. Now, 72 would have worked. We're going to get some big honking fractions with 72. But with the least common multiple, we get the small, and by smallest, I mean numerically the smallest, not quantitative, in other words, not value-wise. It's the same, they're equivalent fractions, but we would much rather have a denominator of 36 than 72. All right, so let's see, 9 times what's 36? Somebody?
4.
Thank you. 4 times 2 is 8, so we get 8/36. And what times 12 is 36?
3.
And 3 times 1 is 3. 3/36.
I was thinking about the wrong one.
Yeah. Now, once again, this would have worked with 72. I'll just do it really quickly with 72. So let's see. We had 2/9, and we want to turn it into something over 72. What times 9 is 72? That would be 8. So we would get what? 70 seconds. And 1/12. We got to turn that into 72. What times 12 is 72? That would be times 6. So we get 6. So, I mean, I wrote, yeah, that's a 7. Sorry. I'm writing with a mouse. Cut me some slack. All right. So those are all equivalent fractions. So even if you chose 72, technically you did correctly. You created common denominators. All right. Back at it. You want more or you got this?
I got it.
All right. Do this last one and we will call it a day. Or I should say we'll go on to the last topic. Do these two all by yourself. And in 1 minute, I will ask who's got the answer. All right, who's got the answer?
15/21 and 14/21.
15 and 14. All right, let's see. I came up with 21 also as my least common multiple. And when you throw that into that, we multiply by 3, that would in fact give me 15/21. And for the second one, I'd have to multiply by 7. That would in fact give me 14/21. Good job. All right, we have one thing left. But what if you had 3 or more fractions? What would you do? So
You do.
Lay down and die.
exactly, right? Just go ahead and
Or
skip this
cry
one
in the
and
corner.
take the minus points, right? Okay, obviously the answer to that is no, you wouldn't do that, but you need to make a common denominator out of 3 numbers. 3 numbers, so it's the same process, you just got to think about 3 things at once. So absolutely positively you might want to
No.
do, yeah, sorry, absolutely positively you might want to write this one down, in other words, the answers. So we're going to count by, or maybe we can logically think this through. Notice 5, 10, and 15, right? 10, the last digit will always be, for multiples,
0. I already know the answer. It's 30.
right? So we're going to only consider the multiples of 5 and 15 that end in 0. So 10, 15 doesn't go into 10. 20, 15 doesn't go into 20. 25, I'm sorry, 30, oh yeah, 30 would be the answer. All right, so this is triple your work, triple your fun, however you want to think about it. But yeah, that's how it's done. So all we would do is do this process.
30, 12, 30, 21, 38.
I didn't get 28, I got 8.
Yeah, my bad.
Okay. All right, questions on any of this? Nothing? All right.
Sorry, I had shoes on the mind.
All right. We won't actually create we won't create the equivalent fractions, but go ahead and take this one right here and come up with the common denominator.
20.
I heard 20. Agree or
Yes.
disagree?
Agree.
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 No, 10.
4 doesn't go into
Never
10.
Yeah, 20.
20 is the correct answer. Now, I typically have some smarty pants at this point point out something. When in doubt, guess how you can always find a common denominator?
Guess.
I guessed 17 and I was wrong. There's one tried and true technique of always finding a common denominator.
It's called a calculator.
Calculator, if you have an expensive one like mine, will tell you that. However, without a calculator, right? By the way, we said 20 was the answer. There's another way of doing this that
You
some
hire
people,
Albert Einstein.
that some people think is the easiest method. They take the 3 denominators and guess what they do with them?
They times
Add
them.
them together.
They times them. So what do you get when you multiply?
20.
You get 40.
You get 40. You don't get 20. It would be really nice if we got 20 because then it would be a really easy process. So are you allowed to use this? Absolutely. Are you assured that it will give you the least common multiple? No, it didn't, but it did give me a common denominator. So sometimes when kids struggle at the LCM, they simply take the denominators and multiply them together. This works whether you have 2 or 3 fractions or more. But once again, you're not ensured that you will get the LCM. You are ensured that you will get a common denominators. So this technique is fine. I just want to caution you and just say that, hey, it will create very large, numerically large fractions. Their values will be the same, but numerically they will be very large. So it's a tried and true technique. I've used it plenty of times. But it's typically when you're dealing with abstract fractions, it's worth the time to find the least common multiple rather than multiplying the denominators together. But if you're struggling with finding a common denominator, absolutely, you can multiply the denominators together. Questions?
None.
Okay.
Give us the test.
There's no test yet. All
When
right.
is the test?
I have to go back to the calendar. Let me see if that was the last thing I needed to talk about. That was the last thing. So we will use the speed function here or speed back through, and we will look, see when. I believe the test is after Thanksgiving. I think.
Yeah.
I don't know. I'm getting all my classes confused. I teach too many of them. Scrolling. That's a lot of clicking. There we go. Yeah, test is going to be after Thanksgiving. Okay. All right. That does it for today. I'm letting you go with about 6 minutes to go. Go to the bathroom, take a break, whatever. And I will see you guys on Monday.
Wait, can we
Goodbye.
get the homework?
Bye.
Sure. Remember, the homework is always on the assignment page.
Yeah.
There's your homework.
Let me see. Seems to be too old. Thank you.
All right. Catch you guys later.